Hello, this is Joe Neville back with another IPv6 video, and today I'm going to show you an Aruba access point booting in a v6 only network. Now I've written up my work recently around this and that's available on github.com. I put it on my own account, it's /Joe-Neville. And in this document, what I detail is address allocation. So if you think about address allocation in v4, you've got static or you've got DHCPv4. But in v6, what we have is static, slack, stateful DHCPv6 and stateless DHCPv6, which I've already covered on this channel for wired. But when we move to a wireless network, we have that extra step where the access point needs to speak to its controller. So what we have is these permutations where we have a choice of address allocation plus how are we going to tell the access point how to connect to its controller. And in this video, I'm going to show you the recommended way, which is by using a DNS. In the document, I break down the different approaches as designs 1, 2, 3, and 4. In this video, I am going to show you design 1 and 3 from the document, which is the stateful and the stateless DHCP approach using DNS to tell the AP about its controller. I think that's the easiest way to do it, and in a subsequent video I'll show you designs 2 and 4, which are the ones where we use a DHCP option capwap. I wanted to keep the length of the video down, and I think this is the easiest way to transition between the different designs. So today we're going to do stateful and stateless, and we're going to tell the AP, so it's brand new AP that hasn't spoken to the controller before, we're going to inform it of its local controller using DNS. Okay, here's the setup. So it's slightly different from the document because I wanted to make it clear that the mobility master, the controller, and my server, they sit on a dual stack network. So I've got v4 and v6 up here, then I've got my gateway, and off of the gateway I've got a v6 only network. The access point is only ever going to be able to communicate via v6. There's no IPv4 down on this link. Let's jump into design 1 then. So stateful DHCPv6, and we've got the two options, so it's the DNS and it's the DNS search list that we are going to be sending to the new AP via DHCP options. So we need to set that up. Now they're running through a summary of the process. What's going to happen is that the AP will boot and immediately it will send a DHCPv6 solicit. It doesn't wait for the router advertisement to hit it, which is fine, that's allowed. It doesn't have to wait for the RA to hit it. The solicit is going to hit the local gateway. So this will boot. It will send the solicit, which will hit IPv6 helper address, which the switch points to the DHCPv6 server up here. The server will respond with the address, so it'll be a /128, and the options, so option 23 and 24. Once the AP receives this, it will send a DNS query, and this is specific to this string. So it's Aruba-master. It sends that to the DNS server, and that needs to be fully qualified. So that's why we need the search list as well. So it's the option 24. So it's for my network, it's actium.home. So it'll be aruba-master.actium.home. The DNS server will reply to that request with the address of the controller. So to run through that, we boot up here, the solicit gets forwarded across, we receive the address that contains the DNS server and the search list, then we do a query for aruba-master.actium.home, and then the DNS server will respond to that query with the address of the controller, which is : 30 in my case. Okay, easy, isn't it? Okay, let's jump onto my server. So I'm using a Windows server for this. Where is it? There we are. This is my domain controller for Actium. So I go to DHCP. Let's bring this over here. There we are. So I've got v4. v4's on, but everything's turned off. Expand all of that. All of the scopes are turned off. Here's my v6. So I'm going to create a new v6 scope. fine. Name is, let's just call, we'll call it design 1. Next, and this is going to be db8-a-60 : so it's a /64. Fine, don't need to worry about that, activate it, make sure the AP is not on. It's not on at the moment. Okay, excellent. So the scope's active. Because I'm going to use DHCPv6 stateful, I can configure in the scope options. So these are the 23 and the 24 option that we want, and those are listed there. So 23 and 24. Let's go 23 being the name server. So that is db8-a-50 for my setup, and it's 10. Add that in, does a check, good, apply that, and a search list, I need the search list, don't I, which is actium.home, add that, good. So those are the options that we need for design 1. That all looks ready to go. The other thing that we need to do then is I'll close that off and I will go to DNS. Here we are on the DNS zone, so I need to create a new quad A, right click new host, and it's going to be Aruba-master, so that the fully qualified domain name is .actium.home, and the address is the address of the controller, so that's 50::30 for me. I will add that in. There we go. So that looks fine to me. I will minimize that. Now, so we've done this part, and let's go on to the gateway. I've got this dual screen. So this is going to be the console. On the left is going to be the console for the AP, and on the right is the connection to the switch. Is that live? Okay. Let us show. I think I've already configured that. All of the details for this actually are in the document. So here I give a breakdown of how to configure the interface. So it's the switch layer 3 interface that the AP is going to connect to. This is really important. So VLAN 60 we're going to be in. Doesn't have a v4 address. Here's my v6 address, which is a /64. I've got the manage flag on. Now, I do mention this in the document. The thing is, the AP boots and sends a DHCPv6 solicit. It doesn't wait for the RA. But in any kind of network, it's good to have deterministic behavior. So even if you don't need this for the AP, if you want your devices, not just your AP, but other devices that are possibly on that VLAN, to use stateful DHCPv6, then it's best to set the managed LAN, because some OS, like I think Windows at the moment, when that well, I know that actually when Windows 10 boots, it will send a DHCP solicit, so it doesn't wait for the RA. But other OS such as like Fedora and Ubuntu, they will wait until they receive that managed flag. So that's a problem with the different OSs. Everyone's life, I think, would be a bit easier if there was just one approach, but there's multiple approaches. What it means is on your router, it's best to configure the behavior that you want to see regardless of the OS. So even though you don't need it, I would recommend using this line managed flag if you're going to go for stateful DHCPv6. Okay, next one is that we're going to send the prefix. Now we need to send the prefix so that this /64, we need to send that in our RA so that our AP knows what is its on-link subnet. That's basically how subnetting works in V6. Doesn't use the mask like in V4, but we don't want clients on the network to use Slack, so we send the prefix, which will have the L flag set so that they can they know that they're on link to this prefix, but with no auto config, so they won't generate their own addresses. They will use DHCPv6. Next line, also very important, is the helper address. So that's the unicast, which is the DHCP server. Because it's on a different subnet, we need that just the same as DHCP v4. I've also got on here the DHCP v6 relay command. That's my switch then. So we've got the switch, the DHCP, the DNS all set up, all ready to go. What I am going to do... Oh, I should show you actually my mobility. So let's log into Mobility Master. Touch ID, go on. Yay, benefits of using a Mac. Right, and let us go... Really all you need to see is that I've just got one controller. I don't have any access points on at the moment. I've set up the auto cert so that it will bring on new access points without me having to manually intervene. There, you can see that. I've got that set. Okay, that's it for that side then. What I'm going to do then is I'm going to boot the AP. Originally, so what I've got here, I've got one of my old, what's this? It's an instant AP. It's a 205 that I've got here that I've had in my lab for a while. But what I'm going to do is, because obviously we don't want it to go to instant, I am going to stop the boot sequence. And I'm going to clear the environment so that it will boot up and not have any knowledge of the controller. I'll just show you what I'm doing. So what I've got, there's the console port on, you've got the console and the Ethernet. I'm going to attach my console and you'll see that on screen here. I'll add the console in there. Let's boot this up. I'm using PoE for this. There we go. We have to be quite quick with this. So it's started to boot. There's the console. There we go. I'm going to purge the environment to make it like a factory default and save the environment with it purged so it's all clear. And I need to set up Wireshark. Let's clear that off. Continue without saving. I'm going to capture on my Mac. Might as well close myself down. Let's expand that. Wireshark on the right. We've got the console. Let's minimize that. We're going to have the console here on the left. Here we go. Let's boot. What I'll do is I'll skip ahead to save time where there's not much activity here because the AP does take a while to boot. Here we can see a router advertisement that's come in, an RA. So this is from my local gateway. If I expand that, you can see, oh, it's not in there, it's in the V6. There we are. So RA, good. We've got the flags here. So it's managed, as we said, so that clients will try to use DHCPv6 to get their address. And then in the prefix info down here, so you've got the onlink flag and the autonomous address configuration flag. The A flag is off, so clients won't use this prefix, the 2001 DB8 A60/64. They won't use that for Slack. Okay, this is where things start to get a bit more exciting. So it starts with trying with v4. There we've got the solicit. So this is the DHCP v6 exchange has happened. Over here you can see we have an address. Then we do the query. I'll bring that forward a bit there. You can see the query there. So that's the query going through. But there you can see the v6 address, and it knows about the controller. That's the controller address, the : 30. You'll actually see the tunnel message come up here on the console as well. There we are. So there's the tunnel message. And this is, does it say destination? Well, this is where it's sending the tunnel to. So that's the address of the controller. And there over here on the right, you can see we've got GRE, ESP. So this is the encapsulated tunnel that's going for. So if we check that, 7823:4A, 7823:4A, that's the source of, that's the AP, and then the master is 30. So you can see those exchanges going on. I'll stop that there then, and let's scroll up so we can drill into those exchanges. Right, we'll bring that across. So here we are. This is the solicit. So what are we looking for? Okay, so here are the option requests actually. This comes from the AP without receiving an RA or anything from the local gateway, and it requests, it takes different approaches. Well, it covers all bases, you could say. So it asks in the option codes, it requests 23, 24 and 52. It doesn't need, if it's got 23 and 24, it doesn't need 52 and vice versa, okay? But it asks, I suppose its job is to try to just get up and speak to its controller. And it asks for a non-temporary address down here. So the server will respond with the address. So this is the address here. So in the identity association non-temporary address, we've got the IA address and the IPv6 address is there. That is this address. That is that, well, sorry, that address there. Yes, that's correct. And then we have the DNS server. So that is 10. Yeah, that's my server. And the search list, so the search list there is actium.home. So it can use that to create the, then you have two other exchanges between the server and the client. Then we have this DNS, so that here is, so it's :4a is our AP at this point, and it sends it to the DNS server, which is :10, and then you can see the fully qualified name aruba-master.actium.home. So we send that, asking our name server to give us the address for that name, and we should get the response. So there's the response, right? And the response to the query is there's the answer. Okay, so that's where it receives the controller information, and with that it can build the tunnel. Let us jump over to Mobility Master then. We're on Mobility Master and we can see our access point. So there is our access point. So it's my 205 managed by : 30. Excellent. Now I've got a v6 only SSID. Let's connect to that. I have config in 0. There we are. Let's expand that. So you can see the address which my Mac has received on the v6 only SSID. Okay, that is design 1. Now I'm going to skip to design 3, which is stateless DHCPv6. It's essentially the same with slightly different configuration on the DHCP server, as you would expect, and on the gateway. I think that's the main difference in the configuration aspect. So in this setup, if you know anything about stateless DHCPv6, we don't get the address from the DHCP server. We get the address via Slack locally using the /64, and then we get the options. Now the DHCPv6 exchange is different as well, because we don't use the solicit, we have to get an information request. I'll show you that in the Wireshark. The main information though that the AP needs for the controller, DNS server and the search list for the Aruba master exchange, that's the same. I am connected back onto my Windows server. What I'm going to do, I'm going to delete that old scope. We don't need that anymore. Okay, and obviously that deletes the scope options. But what we do is we configure the options in here. So I am going to add in, what is it? 23 and 24. DB8A. And it is 50, 10. Add that in. And then the search list. So it's actium.home. Same as before, but it's at a different level. It's at the server level, not tied into a scope. So I think that's okay. Now, the DNS entry is fine. We don't need to change that for this one. Aruba master, that's the same. So what we need to do, Now we've done the server, we need to go over to the switch. So VLAN 60, I need to adapt that. Take off the manage flag and take off this auto config. So let's get rid of that. Okay, VLAN 60, no. Okay. Let's see if it lets us have that. Show run. Okay, so we've taken that off. Now I need to take off this. And I'm going to add in the other flag. Okay, so we've got the other flag and we have, okay, and by default we will send the prefix and it will have the A flag configured, so the autonomous address flag configured. The AP will pick up its address via Slack. Now I've reset the environment. I've done a purge env, save env on the AP. Then we go over to Mobility Master and we'll get rid of the AP from there. Delete that. Okay, that's good. And we are ready to boot. Go. So this takes a while, as it did before, until we get the interesting captures. I'll jump ahead now. Okay, this is where it starts to get interesting. So we have an array, and that array, there you go, it has, so this is the array. We have the other flag set, and the L flag and the A flag is on. I can see that it's already, I'm a bit slow with this, it's already gone through, already got its address and got the master. And you could see there actually, so this is the AP booting with the solicit, but nothing happens, so you don't get a response to the solicit. The RA tells the device that it, with the other flag, that it is getting its address via Slack and it needs to ask for other information from the DHCP server. So what it sends, the AP sends a different type of request. It sends an information request with, so in the information request, it's not asking for an address from the DHCPv6 server, it's asking for the options. So you don't see the request for the solicit includes, there you go, the request for the non-temporary address. It receives an RA which says, no, don't use that, use Slack, the autonomous flag is set, use this prefix for your address, but use the other option for the DHCP options. The AP receives this and sends the information request asking for 23, 24, and 52. It only needs 23 and 24 to get up and running. And then the DHCP server will respond to that with the server options. And here they are. So those are the options coming in the reply. You have the recursive name server. Yep. And we have the search list information. And then with that, the device can do a query. It's now got its address, which would have come from Slack. Over on the console, you can see that there. So it's 75D4. 75D4 sends quad A query request for aruba.master.axiom.home. We get the response for that, and the response needs to be 30, which it is. And then we will see the IKE start to build between 75D4 and colon 30. And then after that, we will have the tunnel built between the two. So if I jump over to, which is essentially it. If I jump over, I will get my access point. There's my access point up and running on a V6 only network using Slack and using DHCP options. So stateless. I should have V6 only. Let's see if we can jump onto that. Control D. IF config. There we are. And then the interesting thing here is that the clients on the same VLAN, they're using the same addressing approach. I'm using Slack and Mac will take two addresses for Slack. So this is why I have got 2 addresses here. Okay, that's it. We saw 2 designs there. One with the AP booting in a stateful DHCP environment and using DNS to learn about its controller, and another setup using stateless, getting its address from the local /64 that's sent in the RA from the gateway, and using DHCP options to find out the DNS server and the search list, doing a query for that, and then getting the controller information. In the next video, I will be covering the other design options, which are stateful and stateless, but using the DHCP option 52, which is CapWAP, to provide the controller address directly to the AP rather than using the DNS query. So that will be the next video. If you like the video, please do give it a thumbs up. If you really liked it, subscribe, and we always want to hear comments from you. It does make a big difference to us if you interact and if you let us know what you want in these videos. But that's all for now. Thanks very much for watching. My name is Joe Neville, and goodbye.